With the growing adoption of technology in every aspect of our life, it is evident that autonomous vehicles will evolve the transportation sector in the coming years. Therefore, automakers are innovating business models and testing their autonomous vehicle models rigorously to fulfill the consumer's demand for high-end and energy-efficient vehicles. But when will autonomous vehicles become mainstream? With the shifting consumer preferences and growing need to curb emissions, the automotive industry is accelerating towards the new world, driven by sustainability and electrification. The infiltration of technology is evolving the automotive industry in a way that the automakers are rapidly innovating their business models and working seamlessly with partners to enhance the autonomy of vehicles. Currently, many semi-autonomous driving systems are already on the road with driver-assisting features like lane assist, adaptive cruise control, ACC, electronic stability control, ESC, rear-view video systems, RVs, adaptive highlights, forwards collision mitigation, FCM, automatic emergency braking, AEB, automatic crash notification, ACN, and others. However, fully autonomous vehicles are not distant from reality. The Google autonomous vehicle company, Waymo, has already tested its self-driving cars for over 10 million miles in rough environments, while Tesla and Uber have also put their driverless cars to testing to approach autonomous vehicles in a phased manner. According to the Society of Automotive Engineers, the level of automation starts from level 0, manual driving, and ends at level 5, no driver intervention, and the auto industry is inching closer towards completely driverless cars as many companies have started working at improving the technology. The 5 levels of automation: autonomous vehicle level 0, no driving assistance. For cars with 0-level automation, the driver is responsible for performing real-time functions such as steering, accelerating, parking, and others, but there are some automated systems in place to assist the driver. The technology support systems may intervene during driving temporarily to offer alerts or momentary action in specific situations. Currently, majority of the vehicles on the road across the world are level 0. Autonomous vehicle level 1. Driver assistance. The new car models feature automated driver assistance systems to help ensure the overall safety of the car and driver. However, the driver remains very much in charge of the vehicle in managing the essential driving functions. Adaptive cruise control is one such feature of level 1 automation cars, which facilitates optimal distance between the vehicle and traffic ahead without any manual intervention. Generally, autonomous vehicle level 1 has at least one advanced driver-assisted functioning. Autonomous vehicle level 2. Partial driving automation. Level 2 driving automation supports primary driving tasks such as steering, acceleration, and braking in specific scenarios, but the driver must remain alert and actively always supervise the technology. Highway driving assist feature installed in Kia, Hyundai, and Genesis vehicles, and Blue Cruise hands-free feature offered by Ford are some of the examples of level 2 driving automation technology. Tesla's new full self-driving capability technology is an autonomous level 2 system, which will continue to remain so when Auto Steer feature for city streets comes with the over-the-air software update. Besides, piloted auto features in level 2 and level 2 plus automation are expected to grow exponentially by the year 2025. Autonomous vehicle level 3. Conditional driving automation. Cars with level 3 automation are able to drive themselves under certain conditions, but not for long distances or motorways. At level 3, the driver does not require to put his hands on the steering, but he must be prepared to take back the control if the conditions change. The level 3 automation utilizes various driver assistance systems and AI technologies to make decisions on changing environments around the vehicle, such as fleet volume, weather conditions, traffic congestion ahead. In 2017, Audi unveiled the A8 luxury sedan with lidar, light detection and ranging technology, claiming to be the first automaker to design a car with level 3 capabilities. Despite the claims, Audi A8 never received regulatory approval for its newly built system, and the engineering marvel is still classified as a level 2 vehicle in the USA. However, Honda in early 2021 released the company's Legend flagship sedan with an approved traffic jam assistance system, which is available for sale in Japan. Other cars that are waiting for regulatory approval include redesigned Mercedes-Benz S-Class and 2022 Mercedes-Benz EQS electric vehicle with Drive Pilot technology. Currently, no Level 3 systems are legal to use on American roads yet. Autonomous Vehicle Level 4. High driving automation. Cars with Level 4 automation do not require human intervention in most circumstances due to their self-driving mode. The advanced driving assistance systems can intervene if anything goes wrong in autonomous Level 4 driving. The drivers can manually override the self-drive mode and operate the car on their own. Due to legislation and infrastructure issues, Level 4 automation cars are restricted to function in limited areas and speeds. Currently, Level 4 driverless technology is used in vehicles designed for public transportation such as robotaxis, that are programmed to travel between point A and B and are restricted by geofencing technology. Sometimes, severe weather conditions may limit or cancel the use of Level 4 autonomous vehicles. Navia, a French company, is building and selling Level 4 shuttles and cabs in the USA that can run up to a speed of 55 miles per hour, whereas Canadian automotive supplier Magna enables Level 4 capabilities in both urban and highway environments. Recently, Volvo and Baidu have also announced a strategic partnership to develop Level 4 electric vehicles for the robotaxi market in China. Autonomous Vehicle Level 5. Full driving automation. Level 5 or fully autonomous vehicles would require zero human intervention, as the vehicle will be assigned to perform the dynamic driving task. These cars would be free from geofencing and would be able to go anywhere and do anything that an experienced driver could do. The cars would not be affected even by the bad weather conditions. Besides, the fully automated car would only require human involvement to set a destination. Although fully autonomous vehicles are undergoing testing in several parts of the world, mainstream production is still a few years away. Can autonomous vehicles solve the congestion problems in urban areas? The onset of autonomous vehicles can provide multiple benefits to the existing road systems, and reduced traffic is one of them. According to a study conducted by the University of Cambridge, a fleet of driverless vehicles working together to keep the traffic moving smoothly can improve overall congestion in urban areas by at least 35%. The optimized traffic flows and reduced number of vehicles on the road can lead to lower incidences of road violence as well as less pollution. Many times, the basic problem of traffic congestion is primarily due to human involvement, such as when the driver does not allow other drivers to change lanes, prevent cars from merging on highways, execute bad driving behaviors, etc. On the contrary, autonomous vehicles prevent drivers from obvious bad behaviors such as blocking crosswalks and enable a cooperative interaction framework to reduce visible congestion. Vehicle-to-vehicle communication, V2V, allows vehicles with advanced autonomy to communicate with each other by broadcasting and receiving information such as road conditions, traffic flow, speed and direction. The sensors start generating a warning alarm in cases of possible collisions if another vehicle is drifting in its lane. According to the USA Department of Transportation, V2V communication can reduce the severity of non-impaired crashes by up to 80% and thus prevent hundreds of thousands of crashes every year. Another significant feature of autonomous vehicles is platooning, which can reduce aerodynamic drag and lower fuel consumption and emissions that help to keep the traffic moving and reduce congestion. Besides, the adaptive cruise control feature can help to adjust the speed of vehicles automatically, determining the speed of other vehicles in the environment and thus keep the traffic flowing. Are driverless vehicles a solution to climate change? Self-driving cars provide ultimate environmental benefits that can help to make the world a better place with reduced carbon emissions. According to the Intelligent Transportation Society of America, autonomous vehicles have the potential to reduce oil consumption by 2 to 4% by 2025. Robotaxis and shuttle mobility have the potential to meet the daily mobility demands and end the mass private car ownership, at least in suburban and high-income urban areas. Many companies have already started operating large testing fleets of shared automated vehicles. Greater convenience, better availability, provision of affordable mobility is expected to boost the adoption of robotaxis in the years to come. The usage of robotaxis and shuttles can lead to reduction in adoption of private vehicles by up to 20% by 2030. Robotaxis are programmed to maintain consistent driving speed and maintain optimal distance between vehicles, which helps to reduce excessive braking and re-acceleration and thus lower emission levels. Besides, advanced driving systems such as eco-navigation, wireless communications, adaptive cruise control, etc. could reduce pollution by cutting down vehicular emissions. While Google's Waymo started offering driverless rides in robotaxis in 2020, Alibaba-backed AutoX has debuted a fully driverless robotaxis, Gen 5, to safely navigate China's complex urban driving situations. Why are self-driving vehicles not mainstream yet? Ever since the evolution of autonomous vehicles, multiple testing operations have been carried out. Billions of dollars have been spent on fickle technology, but still, autonomous vehicles have not been able to match the competence of human drivers. Besides, legislation battles, environmental factors, and safety issues are making it hard for automakers to bring autonomous vehicles on roads sooner. However, ubiquitous, robust, faster, and higher bandwidth communication systems can boost the autonomous vehicle network's capabilities. The cloud system would facilitate engineers to offload a lot of data processing away from the vehicles that could enhance connectivity. Besides, building smart cities with optimized traffic patterns could help to eliminate the infrastructure bottleneck for autonomous vehicles, and thereby make driving more efficient and safer. The introduction of other technologies for advanced driver assistance systems might ease consumers into accepting and using them over time. According to TechSci research report on Global Semi and Fully Autonomous Vehicle Market by Automation Level, Level 0, Level 1 and others, by component, embedded systems, cameras and others, by vehicle type, by region, competition forecast and opportunities, 2016 to 2030. The global semi and fully autonomous vehicle market is anticipated to reach USD 64 million by 2030. Owing to growing focus of automotive OEMs and increasing government support for developing driverless vehicles. Besides, foray of technology giants venturing into the autonomous vehicles are driving the semi and fully autonomous vehicle market in the coming years. According to another TechSci research report on Global Automotive Lidar Sensors Market, by vehicle type, ICE, hybrid and battery electric vehicles, by application, semi-autonomous vehicle and autonomous vehicle, by technology, solid-state lidar and mechanical, scanning lidar, by image type, 2D image and 3D image, by location, bumper and grille, roofs and upper pillars, headlight and taillight and others, by company and by geography, forecast and opportunities, 2014 to 2024. The global automotive lidar sensors market is expected to reach $734.91 million United States dollars in 2024, owing to the rapid progress in autonomous vehicles and increasing demand for connected vehicles.